kind of show you, I've talked a little bit about combinations and permutations in the last day, but let's just take a look at these examples. So number one, if you just look at this textbook, it says, decide whether each of the following is a combination or a permutation. Briefly describe why you don't need to solve the problem. So let's look at part A. In a traditional Aboriginal welcome circle, each member shakes hands with each other member twice. If there are 8 people in a welcome circle, how many handshakes occur? We don't have to figure the problem out. Would this be a permutation or a combination? D? Combination. You're correct. Why? Well, it's just how many, it's basically how many handshakes are possible. So if I walk up to Eileen and I stick my hand out, and we shake hands. So Eileen and I have shaken hands, okay? Does it matter who stuck their hand out first? Does it matter if it was Kim, Eileen, shake, or Kim? No, we just say the pair of us shook hands, that's it, right? That's a handshake. So the order doesn't matter. Agreed? If I say, Abdullah, hi, Eileen, go out of the room, I need 2 students, I need 2 students to go to the library. They walk over to the library, that's just a combination. It doesn't matter the order that they walk into. If I say, the first person I select is going to be the president of the class, and the second I select is the vice president, that's a permutation, because order matters. The first person I elected was the president. So that's the difference. So you're right. In a handshake, it gets to be very, that's the part of this math that, doesn't really, it's hard to explain that type of math because it really is just reading the situation and reading all the, all the details of the situation, and then you deciding whether it's a combination or permutation. There's no formula, right? You just have to decide. So let's do the next one. How many numbers less than 300 can you make using the digits 1, 2, 3, 4, 5? Okay, is that a permutation or a combination? Permutation. Agreed? Because if I take the numbers 2, 3, 4, I could arrange them to be 234, 243, 432. Every single difference, every way I arrange the numbers is different, so it's a permutation, right? This is a combination, and basically how, when they explain, the explanation would be, it's a combination because order doesn't matter. Right? Order does not matter. The order of the people, here it's a permutation because the order of the numbers matter. Order matters, right? What about this one? A car dealer has 15 mid-sized cars. So a car dealer has 15 cars. How many ways can a rental agency buy 10 of the cars? Is that a combination or a permutation? Permutation. It matters the order that they buy them. Yeah.
Just saying.
This would be a combination. It doesn't matter the order it doesn't matter if they order the blue, then the black, and the red, or the red, black, blue. It doesn't matter. They're all going to arrive on the truck. Like, the order doesn't matter. And when he displays them on his car, on his lot, the order doesn't matter at all. A hockey team has 18 players. How many ways can the driver select 6 of the players to ride in the van? Does the order that the team members go in the van matter? No. Combination. What the combination will do is give you how many different groups of 6 can you create? if Eileen's in the group, Eileen and Abdullah are in the group, that's a different group than if they're not in the group. But the order that I select them, like if I select you first, then you, or you, then you, that doesn't matter. Order doesn't matter. So if order doesn't matter, if we go back to if we think about it, if order of a selection of objects doesn't matter, let's think about this for a minute. Let's say that I have Abby and Ben and Carol. Okay, I have 3 people. If order mattered, if it mattered how I sat them on the seat, the number of permutations I would have of 3 people would be 3 factorial would be 6. Agreed? The number of combinations of these 3 people, if I'm picking 3, is going to be just, there's only one, right? There's only one combination of these 3 people. So the number of combinations is always going to be less than permutations. There's more ways that I could, like if I had these 3 numbers, 3, 4, and 7, if I said just grab these 3 numbers, I want you to use these 3 numbers in a math problem, there's only one way I can grab all those 3 numbers. But to arrange them, it would be 3, then 2, then 1. That's 6 ways I can arrange them. So the number of combinations is always less than the number of permutations, because we're dividing out the ordering. The ordering doesn't matter. So what I do is, for the number of combinations of 3 people, I start with my 3 factorial, I start with my number of permutations, and you know what? I divide out the number of ways that I can order 3 people. I divide out the number of permutations. Okay? Let's say I had 6 people. I have 6 people to choose from. How many ways can I choose and order 3 people from the 6? From the large group of 6. Large group of 6. Okay, well, how would I do that? The number of permutations that I would have, right? I only have 3 seats available. Agreed? So I have 3 seats available. How many people do I have for that first seat? How many people can choose that first seat? 6. And then 5, and then 4, right? Can you do that in your head? What do you get? 120? Okay. So now, that's the number of permutations. And that's if order matters. Now I'm going to say, well, what if, just find the number of combinations of 3 people from 6. So the number of combinations is, I take the number of permutations, and I divide out the way that I can order 3 people, right? I divide out 6. So there's only 20 combinations. 120 permutations. Right? Because this represents 6, right? And that's basically the difference between combinations and permutations. The combination formula, if there is one, you just find the number of permutations and divide out the ordering. If you find your formula sheet, which I gotta find mine, I had one a minute ago. So here's my formula sheet. Let's look at your formula sheet again. We only have one more formula to look at and to identify and discover on this formula sheet after the combinations. So let's look at the combination formula. Here's permutations, here's combinations. Now, sometimes we use the formula for permutations. Most often we use the slot system because it's easier for permutations. But I want to show you the link between a perm and a com. This is the permutation formula So to figure out the number of permutations, I did it the slot method, but I could have used all the formula method. Regardless, the permutation formula is n factorial n minus r. So here's the permutation formula. Can you see? N minus r. So the permutation formula appears again in the combination, but you know what they've done? R is the number of objects you've selected. So we divide out the ordering of our objects. We divide out R factorial, right? Which is the number of ways the number of permutations of how many items I selected. See the link between these two? This is just the permutation formula with the ordering divided out, because ordering doesn't matter in a combination. So because you're dividing out, the number of combinations will always be smaller. Okay? Now, the reason I'm showing you the formulas, quite often with combinations, we just rely on the formula approach. In permutations, almost always, if I can, I'll use the slash approach because we have those restrictions, unless I'm told to use the formula. But for combinations, it's usually something that we would do with the formula, and we have our calculator to use. So let's take a deeper look at combinations. So I'm back to page 13 in the pink booklet, in the examples booklet, and we'll just read through the notes again. While a permutation is a selection and ordering of objects, a combination is just a selection where order is not important. Okay? So once again, in other words, a combination is a permutation without ordering. So they're very closely linked. We can calculate the number of combinations of a selection of objects by using reasoning, like using common sense, or by using the formula. So once again, you see this formula that we just saw. I think there's a double exclamation point. There shouldn't be. It should be, it should be an exclamation point here and not a double here. I don't know how that happened. You can just look at, so n CR equals n factorial over n minus r factorial, r factorial. Or you can use your formula sheet, right? And also, there is a combination button on your calculator. So wherever you have your NPR formula, your NCR will be right beside it. So let's just use the formula in our calculator to calculate 10C4. So 10C4, actually use the formula. So we'll use the formula and then we'll use our calculator. I'll show you on my calculator first. Mine is a weird one. I have to go into a submenu. But that's what it will look like on your calculator, 10C4. So I know the answer should be 210. So let's see how this 210 arrived from the formula. So 10C4 would be 10 factorial over 10 minus 4 factorial, 4 factorial. So that's n minus r and r. Okay, so what do we get here? I have 10 factorial over 6 factorial, 4 factorial. And if I was doing this without a calculator, I would use those skills that we developed at the very beginning of this unit when we were doing factorials. Remember what we did? I would do what? 10 times 9 times 8 times 7. And then the 6's would cancel out, right? I'd leave it at 6 factorial, and that would cancel the 6 factorial. And then I'd also be left with the 4 factorial, right? And the 4 factorial would be 4, 3, 2, 1. Does that make sense what I'm doing here? Okay. And then I would do, let's say, pretend I don't have a calculator. What could I do here? I could take this off, and I could cancel that out, and then I could cancel this out. So my bottom disappeared, and I'm left with 5 times 2 is 10, and 10 times 21 is 210. So that's how we got our 210, just manually using the formula. The actual combination formula is quite easy to use. It's just, once again, identifying when is it a combination, when is it a permutation. But permutations are fussy, right? The order matters. they're for passwords, pin numbers, that whole, like P for password, P for pin, P for permutation. Okay, let's try this one, 10C6. All right, let's do the formula. 10C6 would be 10 factorial over 10 minus 6, 6. Okay, so what do I get? I get 10 over 4 factorial, 6 factorial. What do you notice? It's the same, right? We get this symmetry in combinations happens. 10C4 equals 10C6. 6 and 4 are complementary numbers, right? If you, as a sum of 10, 6 plus 4 equal 10. Therefore, 10C4 is going to equate 10C6 just due to the way the combination formula is set up, right? Comment on the answers to A and B above. They are the same. (10C4) and 10C6 lead to the same answers. Because basically 4 plus 6 equals 10, right? Can someone give me another set of combinations that would have that same effect, that would have the same result? I'm going to pick a different n, or pick a different n for me, Adam. Start with a whole complete different n. 8. Okay, 8C3. And what? What's the next combination going to be? 8C5 would also have the same values, etc., right? Agreed? What if I gave you, let's try a couple more like this. This becomes important in the binomial theorem, by the way. What if I gave you 12C something and 12C9? What's the mystery number? 3. What about this? NC, that's an N, by the way. NC16 and NC5. What does N equal? 21, right? Yeah, okay. Explain why 4C7 doesn't make sense. What's wrong with 4CW or 4C7? Yeah. What were you going to say, Joanna? Yeah. Is not possible because, maybe you said because R is bigger than N, right? And we know that N, back to my old problems with my pencils, N must be bigger than R. Literally, it's saying, if I was going to read this in English language, it would say, out of 4 objects, choose 7. It's not possible, right? Okay, so let's see what some of these, as I said before, a permutation, anytime we're talking about a password or a PIN number, it's a permutation. A lot of combinations involve committees, like C's. So the C's go together and the P's go together. But how many committees of 3 people can be selected from a class of 20? All right, that's a combination because order doesn't matter. This is a combination because the order we select the people does not matter. Okay, so if the order doesn't matter, it's a combination, and I would always just, if it's just a combination, I'm always going to use my formula. So the formula would just be out of 20 students, I choose 3. Typically, the numbers are larger than permutations that we're dealing with, so it's a little harder to do formula. And so typically, you'll get your, or it'll be a sequence of combinations that you'll do together. So I'm going to get 1, 1, 4, 0. Okay. There's not as much to talk about with combinations because they're not fussy, right? You don't get restrictions on combinations. We're not restricting, it doesn't matter. Because they're less fussy, because order doesn't matter, we don't have all those, we do have cases sometimes, but we don't have the restrictions with little labels on the slash system. Like, we won't use the slash system in combinations. You can get a case that we'll see a little later on, but let's try this one. Example 3. So the lotteries are picking lottery numbers, or it's an example of a combination because order doesn't matter. It's just if my number comes up, if my lucky number comes up, or my lucky 2 numbers come up, I win. It doesn't matter that the way that they select the lucky numbers. So to play the Super 7, you must choose 7 numbers between 1 to 47. And to play the Lotto 649, you choose 6 numbers from 1 to 49. To win each jackpot, the numbers chosen must match the numbers drawn. Determine the number of possible combinations for each jackpot. Okay, so we're going to do the number of combinations for Super 7, and then the number of combinations for Lotto 649. Okay, so for Super 7, how many numbers do we have to choose from? We can choose from the numbers 1 to 47, so that's 47 of them, right? Out of the 47 numbers, I have to choose the winning 7. So let's see. You can see why this, you definitely need a calculator for this. Okay, so 47, choose 7. This is how many different combinations of 7 numbers there are. So 62,891,499 possible combinations of 7 numbers. That's why on Friday there was a really big jackpot that people, I don't even know if it was won, but it just kept growing and growing because no one was winning week after week. So that's how jackpots can get really large, because there's 62 million ways for these possible numbers to be rearranged, or to be selected, not rearranged, but just selected. And quite often, people, I mean, Canada's not a huge country, population-wise. Not everyone plays the lottery, and sometimes people just stick to their same set of numbers, right? So you can see why there would be far more numbers, possible winning combinations, than even people buying tickets. Okay, let's try the 649. How many numbers do I have to select from in 649? There's 49 to select, and I get to choose 6 of those. So out of the numbers 1 through 49, we select 6. Do you think it's going to be more or less? Okay, let's see. 139, 83, 816. So yeah, it kind of jumps down to from 62 million to 14 million. So this is possible combinations of 6 numbers. That's it. Okay, the actual formula itself is pretty easy, right? It's just understanding when do I use permutation, when do I use combination, right? I have one more example to do, and then I'll give you a little bit of time to work in the book. There aren't that many really challenging questions in the book again, so I'll get some others. I'll let you kind of work through the book a little bit, and then I'll go through some of those examples too. Maybe we'll try a couple of the examples here too. I think I'm going to stop for now. Well, you know what? Maybe I will go on. I'll finish this all up. You guys up for it? Okay, let's read this one. There's a group of people consisting of 15 men and 12 women. Okay? How many 5-people committees can be formed from this group of people? Okay? So someone come up with an answer for me. Okay, sorry. Adam said the 27. Eileen said C5. Okay, that's it. So the answer is 80,730. Everyone's okay with that? Where'd the 27 come from? Yeah, 27 people in total. I'm not sure why they split it by gender here, but here they didn't say anything about gender. They just said how many 5-people committees can be formed from this group. Agreed? Okay. Now let's go on to part B. How many 5-person committees can be formed if there must be 3 men, 2 women? That's why they probably gave us in the separate groups, right? Because now they're stipulating I need 3 men, 2 women. So 3 men, 2 women make the 5-person committee. I get that. Any idea what I'm supposed to do now? They want me to split by gender. They did give me info split by gender. What would you say, Eileen? Does order matter? Does it matter how I select the men, though? It doesn't matter, right? They want me to pick 3 men, so it's still a combination. It's a good thought. There is something different about this, though, right, Eileen? Order doesn't matter, so it's not a permutation. So I'd only use the slots if it was a permutation. So let's write that down too. Order doesn't matter. It only matters that I pick 3 men, 2 women. Any other suggestions? Okay, I'm going to give you a bit of a clue. This is what they want me to do, right? I don't know if this makes sense to you, but I always think of what they want me to do in words, and then I translate my words to math. So this is what they want me to do. Out of 15 men, choose 3, and out of 12 women, choose 2. Okay. How do I translate that into math language now?
15C3 plus 12C2.
The only thing about is that plus sign. In this type of math, I think I might have told you guys this at one point. I thought I did somewhere. Let me backtrack. You know what? I don't see it printed anywhere. But I wish I thought I wrote it at the top of the page. Remember when we were doing cases before? and I said to you, I don't know, I said or means add, and means multiply. So the only thing that's different is this is a multiply. Okay, so I'm going to write that down now. Remember, in this type of math only, and means multiply. Or means add. When you're moving across the page, you're multiplying. When you're adding up cases, you're adding. So because this is occurring at the same time, like it's the same committee, it's an and situation, and is multiply. So we've got 15C3 times 12C2, and there are 30,030 different combinations of people. Different combinations of, I should say, not just of people, I should say of 3 men, 2 women. That's how many ways you can select 3 men and 2 women. Okay. Onward. Let's try the next one. This is as tough as a combination will get. This type of deeper thinking on a combination. Determine the number of 5 people committees, okay, so it's the same number of people on a committee, that can be formed if there must be a majority of women on the committee. What does majority mean? Okay, means more women than men. Okay, so you're still restricted to, you only have 5 people and you only have these 15 men, 12 women to pick from. So if I have a 5-person committee, what are the possibilities then? What would this committee look like? What would the makeup of the committee look like? 3 women? Okay, so it could be 3 women. How many men would be? And 2 men? Or 4 women and 1 man. And there's also another possibility. 5 and 0. Because they don't say that you have to have any men, okay? So do you remember what this is? If I have an or situation, this is called a case, right? Or we call them a case. It could be case 1 or case 2 or case 3. Agreed? Okay. So 3 men, 2 women. That's almost this one, but flipped, right? So the women are first. So what would that look like? That would be 12C3 times 15C2. Agreed? What would this one look like? 12C4 and 15C1. And then lastly, 12C5 and 15C0. And remember what or means? Or means adding. So once I find the answers, I'm going to be adding up all my answers. What is 12C3 times 15C2? Did you try this one, Adam? Did you get 23,100? Yeah. Okay. Okay, the next one I got was 7425. Okay. And then the last one, 792. So it's situation or this situation or this situation. I add them all up. Three, 1, 3, 1, 7. different committees that could be formed with women on the majority. And minority obviously means less women than men. Okay, how about take a look at the last part, the last one, D, and just see what you can make of D. Is that your phone dinging? Okay, got any ideas for this one? Peta is one of the women in this group, so she's one of the 12 women, right? Determine the number of 5-people committees that can be formed if Peta's on the committee. Okay, so there are no other restrictions, right? Like there are no other, so it's kind of like a part A. It's just saying out of all these people, you get to pick from everyone. There doesn't have to be a certain number of men or women. The only stipulation is Peta has to be on the committee, okay? Eileen says 26C4. That should be less than this, right? Because now that Peta's on the committee, she's taken out of this group. So let's see. How many people agree with Eileen? Neville does. Why do you agree, Neville? I do too.
Well, you're supposed to have 1C1 for Peta, but that's just one. So
You could say like out of one Peta, I choose Peta, and that's true. You could also just think of it this way: she's already sitting in the boardroom waiting for you to join her, right? She's already out of the group. So now you're down to 26 people, right? And you only have 4 seats to fill because she's filling one of them. So you could just even think of it commonsensically, 26C4, and that's the answer. How many people thought their way through this? Eileen, Neville, does it kind of make sense now in a way? Okay, so that's it for combinations. There's less to talk about with combinations. There's less for me to go through because they are simpler than a permutation. There's no fussing up. You just have to decide, is this a combination question? I'm going to give you a bit of time now to work on, there is a bit of practice to be done in the examples book. There are examples that they've done for you again that you could look through, examples with solutions. I didn't go through an example with like solving for an unknown in the formula, but there are a couple in the exercise 8.4. So I'm going to give you some time, work through exercise 8.4. It goes all the way to the next, so there's 1 through 15. Do your best. It's kind of a random selection. They throw some reference to permutations there too. I didn't, this is another way of writing a combination, by the way. This is an old-fashioned, I'll just show you. I mean, it does references it in the examples, but when you see this is rarely used anymore, by the way, you guys. This 8-5, but when you see an 8 and a 5 like that, this means 8C5. That's what that means, okay? It goes on to the other page. There are a couple of formulas to solve too, but most of them are just giving you exposure to the type of question you'd see in a combination. So work on exercise 8.4 for a little while, then I'll take up some homework questions. I said for the last half hour,